Thanks a lot, Eugene. Hello, everybody. Could we just confirm that you can hear me, please?
Sure.
It's a pleasure to be here. Thank you, Eugene, and your team for putting this together. Bruno and Claire for really spearheading deep learning in Indaba, and also for the people who have managed to come back in this session, but also for the wonderful presentations that come before. Why am I really here? The foundation of my work, which I'm going to be presenting today, is something that Ernest hinted on a bit earlier, which is how do we get more impact out of our AI research? So I am based at the AI Research Lab. My name is Mutembesa Daniel, and my presentation will be on mechanism design. So let me share my screen so that we can have this presentation going. Okay. Oh, sorry. Present, not share. Sorry. Great. Are you able to see this?
Sure thing.
Okay, great. So the foundation of mechanism design is from game theory. Game theory is a subset of economics, and now it has a merger between economics and computing. One of the classic scenarios of game theory is when two prisoners have been caught committing a crime, and the police wants to get a confession out of them. And so usually there's this scenario where, player one and player two means prisoner one, prisoner two, each have two options, either to confess or to keep quiet and not snitch. And usually the rewards for that and the penalties for that are different. In other words, player one, if they confess, and also if prisoner one confesses and prisoner two confesses in the first left box, each will get 2 years. If prisoner one confesses in the upper right and prisoner two refuses, prisoner one gets 4 years. Prisoner two gets 0 years if found guilty for prisoner two, and the like, and so on. And so why did I start from this angle? Here, what we are doing is that we are literally designing a game which the prisoners must go through. So we already have a structure of really what we want. It's a procedure of what we really want to see happen. In other words, we want people to confess. So you bias the game to have rewards for people that say confess, and to have higher penalties for people that refuse. I started here because mechanism design is a subset of game theory. In other words, mechanism design, instead of focusing on the game, the mechanism design asks, what objectives do we want to fulfill? Okay, so it's more a reverse of the game theory setting. So what it does, it first of all assumes that people are rational, meaning when we say rational, we mean that given options of anything, a banana, an apple, you will always first evaluate where, what is giving you more cost benefit as a person. And that evaluation of going with the most cost beneficial item or decision, that is what we determine, we'll say as rational. So we realize that when people are interacting with others, where there is different influences for their interaction, they are always acting strategically, okay, depending on the rationality. So in mechanism design, we are trying to design incentives that influence people to act in a certain way. So in the case or the cases that I'm going to present, we are telling people, can we I mean, we can give you some, say, some incentive to, as a farmer, to go and collect data. But if you go to a place where nobody else has collected data, that place would attract a higher reward. So that is rationality and that strategy. Of course, the person you're working with or the farmer has to decide whether um, to engage or not. Why is this important? This is important because the bulk of the presentations that we have seen uh, all have solutions which are strongly geared around community. And so when you have artificial intelligence-based solutions or any computational solutions, we have seen a significant um, barrier for them to be adopted within our communities, taking from the keynote of the comments from our first keynote, where the professor said in his village Nakaseke, while he uses a tab, people are not able to use these technologies down there. Well, because of several things: cost, usability, and you mentioned the like. So this is what really led me under initially my mentorship under Dr. Ernest on this crop health. We wanted to know, okay, we would like to develop AI-based toolkits for bridging crop health challenges. But of course, any data science, any machine learning pipelines, any AI pipelines are data hungry instruments or techniques. So we needed the data. That was the first. And the second is that once you need the data, then you also need community engagement, people to continuously use these models. So my first case is mechanism design for incentives in crop health community sensing. So we have a pipeline, and this is known as the AdServe pipeline. I would like to acknowledge that a number of people have contributed to, developing this pipeline, implementing it, managing it. From lead engineers, Solomon Jerry and Chaudhry and Ernest, who was also initially the principal investigator, to Eugene, yourself, and quite a number of the ladies, Claire, Samiha, who all worked on models around this. So AdServe is really a pipeline where different people around the country can use this mobile app to send a real-time image to a central server. The central server, would be duplicated between us and the National Agricultural Research. And so the question is, how do you get people to report images from around the country? You've given them an app that is on a mobile phone, but you need several things. One of them is for them to report weekly. Okay, if anybody has used any reporting tool, you understand that people get fatigued after reporting weekly because they need to see where is the profit, where is the benefit, where is the incentive. Secondly, you need people to go to areas that they don't usually go to. And so this is known as an exploration problem. So, given these two objectives, mechanism design, really what it does is that it starts from the end, which means it looks at the objectives that we want to achieve. We really don't know what mechanism we're going to use. So looking at the objectives, then we ask ourselves, what does the farmer want? What does the agricultural researcher want? And so we set up what is known as a game theoretic setting just to understand, okay, we have an application. What does the application include? The application includes what is known as a sensing task. It means take a picture, annotate the picture, tell us, is it a cassava? Is it beans? Is it maize? Give us a bit more information. Do you see any disease? So those are all sensing tasks. One of the main sensing tasks is adding a geolocation to the picture. And by the way, AdServe is really open source, so you can find it on Google if you'd like to use it for some of these things. Yes, so there is a sensing task. There's the agent or the agents who are known as the farmers who are in the field. Then we try and see what does the agent really report. The agent always, or the farmer always sends a report that has tasks completed and the location. But we understand that there is some sort of cost. You know, a farmer doesn't go out to collect images for you for free. They have to walk, as the initial presentation showed, of distance measures of how far farmers go to collect data. They spend their time, they charge their phone and batteries. And so we have started from the objectives. How do we tweak this scenario so that we pay people to engage more and frequently and every week? And then we also pay much more or more incentive for people who go to areas that haven't been explored. And so usually we start understanding that during things like what are known as utilities. A utility is really what I talked about in the first place, known as a cost benefit analysis. You're trying to find out, is this beneficial? Does it benefit the farmer, you know, vis-a-vis the cost or the amount of effort they're putting in? And so one of the ideas is that we realize that the utility of a farmer is, you know, if they're receiving more incentive than effort, then that would be on the positive side. If not, they're not able to participate. For the requester, who is known as either us or the agriculture institution, they're trying to say the number of reports that we get, the valuation of those reports should be more than the payment that we give out. So we come up with something like a payment mechanism or a payment function. And this payment function would really don't really bother a lot with, you know, the whole equation. But the idea is that the payment function is doing two things. It's giving a compensation for you know, the person's effort, the internet, the walking, the time, the battery, you know, because they have to charge these phones in very remote areas. And so it's giving a you know, a basic compensation, because remember, when we are using setups like crowdsourcing, you're enlisting the help of volunteers. As the previous presentations mentioned, it's important because it allows us to do mass or large scale sensing. So the first one is really compensate them, and then the second function looks at what is known as a bonus, which says if somebody collects pictures from their own garden or from the neighbor's gardens, those, you know, they should be given compensation that is relative to how much work they have done. But if they go over and beyond and go to another district to collect data where we don't have any data, there should be bonus associated to those distances or to that extra effort. And so what I'm talking about really in mechanism design is that we started at the end, which is the objective of mass collection or of large scale crop health sensing, and came down to who are the players and what do we need to do, what do we need to pay, which factors do we need to pay more. This is a clear result of what happened in 2016. Our first deployment, we had 29 farmers, and over a period of about a year and a half, they collected about 7,000 images. And when we developed these second level incentive mechanisms for the second pilot, we had a bigger cohort and about 175 farmers, but these managed to collect about 87,000 images. Now, if you realize, it means that in the first pilot, we're getting about 200 images per person. And in the second, we're getting double the number. So it just shows you the effect of incentives. And if you model an incentive mechanism, you know, based on the objectives you want to achieve, it could get you there. Currently, in our third pilot, which is joint work between Dr. Joyce and myself and the team at the AI lab, you know, we've reached about 400K in total. You're looking at about 500,000 images. And so this is just the objective. You know, you start designing the incentives based on the objective. Again, this allows for people to interact more with the phone app, which has diagnosis, multiple services, diagnosis. The farmer can ask questions to an expert, but can also collect data. Yeah, so this is just one case example. I'll just run through the few other case examples of where mechanism design plays a central piece in impact of AI within society. So we have credit scoring. So if you are wondering what credit scoring is, if you go to the bank, they have to assess how credit worthy you are to give you a loan. If you're asking for some amount of loan X, they have to look at your assets, and they look at also they ask your employer and things like that to understand how do you pay your taxes, how do you do your revenues, uh, all this. So all these things contribute to what is known as your credit score. Unfortunately, for the rural farmer, who are many, who are literally 90% of production in a country like Uganda, do not have credit scoring, uh, whether by mobile money or by assets, because they're really, they just have 1 acre. And so it's costly for a bank to go down to really understand, should we give these people loans and how much? The bank will end up spending much more money when they're going to give out a loan of 100,000 or 200,000. So what we did is there's this joint work. We're trying to see if a farmer, a smallholder farmer, is asking for a loan, can we go to the fellow farmers within their community and ask them to tell us, what do you think Mutembesa's, by the who's me, what do you think Mutembesa's credit worthiness, credit score is? If we give them a loan of, 100,000 Ugandan shillings, how do you rate their, and so this is very low cost. Uh, it reduces, $100 due diligence to about $10 due diligence. That's tenfold. But the trick with this is being able to incentivize the people in a way that they, again, you start from the objective. Mechanism design, you start with the objective. The objective is, can we have them tell us the truth? And so we've designed a small experiment where um, you have two control groups, and one mechanism experiment group. The two controls, they're really very simple. We go to the first group, we tell them X number of farmers have applied. We will not give you any incentive. And what you tell us about them or your credit score will not affect their loan. They will receive a loan. So the second control group, you tell them what you tell us won't affect, and whether people pay back or not, you will still get an incentive as a recommender. In the third mechanism study group, we're telling them that the rating or the credit score you give to your fellow farmers will determine who gets a loan and who doesn't. But in addition, if they don't pay or if they pay, we shall give you an incentive based on their payment record. So if it's low, we will use this truncated decision scoring rule. If it's low or no payment or somebody has defaulted, you don't get an incentive. But also we start to understand who recommends or who knows other people better. So this is sort of incentives or mechanism design of incentives around uh, credit scoring within a social setting. Right. So yeah, I'll just run through that, and then I go to the next. Um, we are looking at mechanism design for incentives in agro recommender systems. So during our experience over the years working with farmers, we realized that once you give farmers information like their crop has a disease, which the AdServe does and which many applications do, the farmer has it, the crop has a disease, they're always looking for, so what should I do? And so this joint work between Joyce, myself, and and Bo is really looking at two things basically. The first is to be able to use machine learning, and I acknowledge the teams that work on this. The first is to be able to build a machine learning recommender, which takes in a bunch of questions and a bunch of answers and tries to develop a recommender model that allows the recommender to, when it gets a new question, it can, it can be modeled to answer that question depending on historical data, or answer the question depending on if it needs direct injection from other like weather applications or market information. The work is called expert in the loop, in the sense that if the recommender is unable to recognize the question, or if it's a new question, then the recommender would succeed and push that to an expert. What is the motivation for this work? This work is motivated by the fact that two things. One, we have phones playing a big part in decentralized advisory services and early warning. AdServe included, but many others throughout East Africa. Two, from this starting page, you realize that there's a handful of crop experts or crop extension members who are, commissioned to serve millions of farmers. To give a context of the magnitude of this, there's only like 20 maybe cassava experts who are serving 2 million growers of cassava around the country. So the first layer is, should be able to relieve the experts from the burden of answering questions that they have already answered. That is using the recommender. And then the second part, which is an incentives part, or this mechanism design part, is to be able to incentivize farmers to do two things: to ask for recommendations, and secondly, once they get a recommendation, to tell us or to give us feedback: was the recommendation appropriate? So the work is really focused now on looking at a reward scheme that engages with the people, because that back and forth engagement allows you to develop to improve the performance of a recommender machine learning system and the like. So you can see that mechanism design really plays the central bridge here in that community engagement, where the people have something they want, and so you should be able to interact with them in a strategic way, depending on what output you'd like. And so this is the framework. Basic question would be, the farmers would ask, what crop should I grow this season? The recommender system would then look at previous questions and see if it matches any. The model should be able to intuitively answer if it already has similar questions from farmers within that region. If it doesn't have, or if it's unable to pull them from some sort of information website or endpoint, then it forwards that to an agricultural expert who would then calibrate the recommendation back, or given a recommendation to the farmers. What this does is we realize that 78% of the farmers are always asking repeated questions. So they can receive a direct answer from the recommender system. But for the smaller percentage that ask newer questions, those can definitely now be filtered directly to the expert. And on the upper side, once a recommendation is given, whether we have advised for a crop or for a fertilizer, that recommendation, we would like the farmers to evaluate that recommendation. Now, there needs incentives, or you need to be able, if you want, people to evaluate a recommendation, that's more work. So you need to be able to find a way of giving them incentive. And the incentive doesn't have to be monetary. There are various incentives. Some incentives are service-based incentives. Some are intrinsic incentives, meaning that they promote their social value. Some are extrinsic, like money, and things like that. So yeah, that's in recommender. So we have also in agriculture markets, it's work that has been done previously before here at the Artificial Intelligence Research Lab by Richard Sechibule, Dr. and Kevin Kevin Layton Brown. And the idea is that people can send a farmer, a willing seller can send information about how many crops that they want to sell or which crops, the amount and the price. And also a willing buyer can, give details of how many crops that they want to buy or which crops, the amount and the price they're offering. So really they used something also in mechanism design, which is known as a market clearing algorithm. You start with the objective. The objective really is how many people can we match? How many farmers and buyers can we match? And of course, the objective would be based on how close are they? Are they in the same district? How close is the price? How close between these two requests is how close is the quantities that they want? Are they on a specific area? And so these things are some of the things where you see, solid use of mechanism design, and you can incentivize either side with any one of the incentives, whether the incentive could be a reputation-based incentive, like if a farmer is delivering bad quality, you can put an incentive or a penalty there so that every time a farmer delivers bad quality, their reputation drops. Like just the way we see the applications that are used, star and the stars in most of the application, 5-star evaluation. And so those things are some of the things that mechanism design is really the center heart of doing these things at scale. Okay, that said, I probably would just give the last overview looking at the opportunities that exist for mechanism design in incentives. Currently, there's a piece of work which is trying to harness border borders, which are the local motorcycle taxis, for fine grain spatial quality sensing. In other words, the border is fitted with already fitted with an air quality sensor. And the idea would be to motivate or to incentivize these people to go to regions that are not usually, where people don't go to, or regions where there's no data, or to incentivize for just even the basic, can they go to an area every day at a specific time, so that you have these fine grain and real-time air quality tracking. The work that was shown a bit earlier, low-cost microscopy for disease detection, like malaria, that was presented by Rose Nakasi. A scenario like that, if you were to go to a hospital, you would imagine people have reservations on using an automated system. So you'd have to design a mechanism and incentives around using an automated setup vis-a-vis the traditional setup. And this can be anything about the cost and things like these. So you really, the idea of mechanism design that I wanted to present today is it's a very simple process, which instead of going out, which is the standard way, you go out with something you want to do and the setup. Instead of doing that, mechanism design takes the reverse approach, as you saw in my introduction. It starts with the objectives that you want to achieve and then builds back to designing the participants. What do they want? And then looks for where exactly to insert incentives so as to achieve those objectives. And so, yeah, this is, again, central work, as you can see, could be deployed and usable in, reinforcement learning, for route discovery, for yeah, and it also could be used, I think most of what you're doing, even for feature selection, that is some sort of mechanism designed for some of our colleagues that use a lot of feature selection tools. So yeah, thank you very much. I'd like to recognize the lab that I'm part of, and the team and the attendees here. I hope I'm in time. Thank you.
Okay, thank you.